Now students, we are going to understand the sheet metal layout, or this is also known as the scrap strip layout. So basically it is a layout by which the blanks are produced by the sheet such that the percentage utilization of the sheet is maximum. So basically this sheet metal layout is used in only blanking operation. Okay, it is not used in the punching or piercing operation. It is suitable for only blanking operation. So from this layout we can have the maximum utilization of the sheet from a given. Okay, so see here, these are the this is our sheet of length L and width W. Okay, and thickness T. Okay, this is our sheet available, and we have to produce these circular blanks from a given sheet, and the feed is given in this direction. Now you can see here the distance from the lead end to the first part or blank that is going to produce. This distance is known as the scrap bridge. See, this is the scrap bridge. So, or the distance between the blanks that are going to produce is a scrap bridge. So, and this gap or this distance is the front scrap, and this distance is a back scrap. Okay, so here we are going to have the front scrap as a and the scrap bridge as a B. Okay, and this total blank sides plus this scrap bridge, this total distance is our advancer, or we can also have this feed. Okay, so if this diameter of this say blank is D, then the D plus this small a is our feed. We can say it as S, or here we have noticed as advancer C. Okay, now so we have already seen here the distance is generally given by the equation. The distance a here, that is thickness plus 0.015 times height of the blank that you are going to produce. Distance b must be large enough to prevent the scrap from twisting and wedging between the punch and die, and the rule of thumb is to make it at least equal to 1.5 times of thickness of the sheet. This is for B. B is our what? Scrap bridge. And A is our what? The front or back scrap. Okay. So commonly used values for this B we are having. So B is our scrap bridge. How much? So if the sheet thickness is less than 0.8 millimeter, we can take this B as 0.8 mm. If the material thickness or sheet thickness is ranging from zero point 0.8 to 3.2 millimeter, then we can use this value of B as equal to the thickness of the sheet. And when the thickness is goes beyond 3.2 millimeter, we can use the value of the scrap bridge as 3.2 millimeter. Okay, so what are the factors affecting this strip layout? Number one, the grain direction. The strips are usually available in the coils. An important point that has to be considered is the grain direction, or the direction in which the rolling was done for the sheet. Okay, the strip should always be fed and processed in the direction of the grains. That is the one thing. So the direction in which the grains are oriented for the sheet while during the production. So in this direction only we should feed the strip. Okay, so this is the first factor which is affecting the strip layout. Now second is the cost of tooling. The tooling needed for press work is quite costly and take a long time to design and manufacture. Of course, the punch and die are very costly equipments, very costly tools. The compromises between the reasonable tool cost and optimum layout is often required. For high production rates, however, tool cost per piece becomes less. Of course, if your production rate is so high, then tool cost per piece is goes down, right? And more attention should be paid for economy of the material and ease of the operation. Third factor that is affecting the strip layout is ease of operation. The strip has to be planned in such a way that actual feeding into the die is as simple as possible and location of the hole is accurate. The strip may get jammed if there are any projections or contours are present. The strip may also need to be turned over when feeding for different passes. Then the fourth factor is availability of the standard strip widths. The strips are available in standard sizes only. As far as possible, only these sizes should be used because they are available easily and faster. Uncommon sizes have to be ordered specially and are usually costlier and have longer delivery periods. Vehicles. So definitely we have to go with the standard ones. Otherwise, we have to pay extra for that, and there will be a larger lead time to get it in our hands. That is, uncommon sizes have to be ordered, special order we have to make, and they are very costly, and we have to wait for the delivery of these non-standard size or uncommon size. Fifth factor is strip or coil stock. The available stock may be in the form of a coil or strip. A strip may be passed through the die any number of times, but coil stock is usually passed through the die only once. Coil stock is used when production volumes are high and metal thickness is low. When to use the coil stock? When the production volume are very high and metal thickness is low. Okay, and strip may be passed through the die any number of times. Strip can be passed in the die for many number of times, but coil is passed in the die for a single time or once only. Here the feed in this case is usually automatic in the case of coil. The strip stock is used with the low production volumes and thicker metal sheets. Strip stock, where to use strip stock in the low production volumes and when the sheet is a thicker one. And here this stock feed is mostly manual. Then the sixth factor is the direction of burr. A burr is produced on the die side of the scrap strip and on the punch side of the blank. Sometimes it may be desirable to keep the burr on a particular side. It is, however, not a very important point in most of the cases. Narrow run or wider. This is the eighth factor. If the length of the component is more than its width, it is necessary to make a choice whether to keep the length side or width side towards the feeding direction. So this is a decision has to made when the length of the component is more than the width of the component. Okay, so this is the decision has to make. So how to feed this? You can see here this is the narrow run, this is the feed direction, and this is the wide. Okay, so you have to take a decision. So as shown in the figure, if the narrow side is towards the feeding direction, it is called as a narrow run. Otherwise, it is a wide run. Now, from this layout, what we are going to find out the material utilization factor. So What is material utilization factor? The economy of material is used is usually expressed in terms of material utilization factor, and it is defined as the area of sheet utilized divided by the total area of the sheet, or you can also say like area of the blank skirts divided by area of the sheet used. Okay, so this is in percentage. So we are having here the one blank of dimension, say W into H is produced, the sheet used will be W plus B into H plus 2A, and this material utilization factor will be W into H divided by W plus B into H plus 2A. Please look at the diagram. Okay, and this is not a fixed layout. Basically, we can keep on changing to get the maximum utilization by rearranging the layouts. Okay, see here, for the utilization point of view, we can arrange the blanks from the sheet like in this fashion, like this fashion, or like this fashion. This is single row, this is double row, or this is a in single row we are having double pass. Okay, so this is about the strip layout. Thank you.